Hello, my name is Todd Hayes, and this is my first lab report for Physics 2. So this lab report was mostly focusing on electric fields and charges, and we did that through experimenting and observing the interactions of various charged objects, and seeing how they interacted with neutral objects as well as charged objects. And we did this, our charged object of choice was a U-tape. So we took tape, we applied it to a table, we applied some more tape on top of it, and we ripped it apart. And that either left or removed electrons. And through this experiment, I came to the conclusion that you had a net positive charge on this tape that you ripped off, meaning that you left charges behind. And we found that there was that charge by ensuring that we induced a charge by ripping it off and then making sure that it was attracted to a neutral object, as all charged particles are attracted to neutral objects. And then took that and interacted or had it interact with a known charge, namely a pen rubbed on cloth, and saw that we were able to have a positive charge on the U tape. So moving more into the nitty-gritty, one of the major limitations of this experiment that I think might have messed with some of my numbers a little bit was the most accurate ruler I had was on a multi-tool, which is less than ideal, especially given you can't ensure that the bottom is completely flat because that bottom is rounded. And it was also a very humid environment. I'm not sure exactly why this was a problem. However, the lab guide did mention that you could have issues if there was too much humidity, so I went ahead and noted that as a potential source of issue. So instead of putting formulas all up on the screen and walking through the same math you saw in lecture, I wanted to go ahead and look through the code and walk through it in this fashion. So on the left in our setup, this is also where you see the mass and the length of the tape, where the mass is in kilograms and the length is in meters. And so by having 5 inches and converting that to meters, I was able to have the length, and then I assumed that the 1 gram per meter was true as I did not have a very accurate scale. And so I just had to divide it by 1,000 to get my mass in kilograms. And then this distance is representative of the distance once they started floating. And we knew that once they started floating, that was the distance that mattered, since once you had the tape on top going up after holding the tape underneath it, once it was still, you were able to know that it was exactly counteracting gravity because it could have also gone higher if I moved the tape higher. But as I dropped it lower, it did eventually drop outside of where the field was able to overcome gravity. And then for the forces, I have the mass of the tape times the gravitational constant. And then I start with this electric force as the absolute value of that. And that is because I know that they are exactly equal and opposite, so I don't actually have to calculate what this value is. But this will come and become important in just a moment. So I start with my observer and my particle, and then we can find the actual distance. And then from there, we can actually figure out what exactly the charge on this tape is, because if we know that it is equal to gravity, we can do the formula for the charge in reverse and solve the equation for Q instead. And then through that, we're able to find the charge on the tape, and then we can divide it by the amount of charge on an electron to be able to figure out how many electrons we left behind. And then after scaling it for the purposes of the image being a little bit more readable and adding the arrows to represent our forces, we're left with this. So I was able to find that the actual charge on the tape was 3.72 times 10 to the negative 9 coulombs, and that the electrons left on the base tape, once you count or take account of how much a charge is, was about 2.3 times 10 to the 10 electrons that we left behind on that base tape. One thing that's important to note is there were a couple assumptions that I made, notably that there was no air resistance, also that you could assume that these were point charges, and that there was an even distribution of charge along the tape. And the reason that we can assume those is that since we are looking at how they are interacting on a linear scale, for example, a linear section is raising a linear section, you can assume an even distribution since there was no waviness in the tape. And because of that, we're able to represent it as a point charge by looking at an infinitesimally small piece to be able to figure out what exactly the charge is happening. In the same way that we can model gravity, and that additionally brings in the concept of superposition. Because gravity is equal and opposite, the arrows are the exact same length. Also, this positive charge means electrons were left behind. And again, we experimentally validated that by comparing it to a known charge of the pen with some cloth. Additionally, some extension questions. If electrons were positive and protons were negative, nothing would change here. because if we consider the same thing with point charges, it doesn't matter if they're positive or negative, they will both attract neutral objects and they will repel themselves and attract opposite charges. Additionally, whenever you have a charged object touch another object, it's going to want to distribute some of that charge. And so we wanted to make sure we handled them as little as possible to be able to limit how much it was distributed. That way we could figure out just how many electrons were a result of ripping the tape off. Thank you so much for watching the video.